Welcome to episode 117 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes the object so interesting to astronomers. So, I will now run the random number generator.
Hello.
The generator has returned the coordinates of 0 hours, 33 minutes, 0.0 seconds right ascension, and plus 62 degrees, 55 minutes, 54 seconds declination. These coordinates point to the star Kappa Cassiopeiae. This is a blue supergiant star, estimated to be 34.5 times the mass of the Sun, located in the constellation Cassiopeiae at a distance of roughly 3,070 light-years, or 940 parsecs. The brighter stars in this constellation are all between magnitude 2.2 and 3.4, and form an easy-to-spot W shape, but Kappa Cassiopeiae is magnitude 4.2, which means that it's only about 1 or 2 magnitudes brighter than the faintest stars that can be seen without a telescope, and therefore really difficult to find without a star chart. One of the notable things about Kappa Cassiopeiae is that it is a variable star. It belongs to a class of stars named Alpha Cygni type variable stars after Alpha Cygni, the first star where these types of variations were identified. The brightness variations in Kappa Cassiopeiae, which are very small and very difficult to see without the use of modern telescope instrumentation, occur with multiple time periods, but the strongest variations take place on a period of 2.7 days. These variations appear to be linked to instabilities in the star's outer layers. While some astronomers are interested in the variability of Kappa Cassiopeiae, others are much more interested in the funky hemispherical shell-like structure of gas and dust located on one side of this star. This structure, which has an inner radius of about 2.4 light-years, is called a bow shock, although some references call it an atmosphere, which I thought was as confusing as heck, so I am calling it a bow shock. It formed from the interaction of the stellar wind from Kappa Cassiopeiae with the interstellar gas and dust that the star is moving through, and because interstellar dust radiates infrared light, this structure looks really bright in the infrared. The dust also has a very wispy filamentary structure that has been very challenging to describe using physics models, but which has provided interesting insights into the exact nature of interactions between the stellar winds and the interstellar medium. While the stellar winds from all stars, including the Sun, eventually collide with the interstellar medium surrounding those stars, those collisions do not normally produce bow shocks like the one found near Kappa Cassiopeiae. As best as I can tell, this is because of 2 reasons. First, this star is a really big, really bright, and really hot star, which means that it has very strong stellar winds to begin with. More importantly, though, this star is a runaway star. This means that Kappa Cassiopeiae was ejected from the location where it formed, most likely through some sort of gravitational interaction with the other stars in that location, and it is now moving at a relatively high velocity through a random part of the interstellar medium, thus producing the bow shock we see today. So that summarizes what astronomers find so interesting about Kappa Cassiopeiae. I could say that summarizes what astronomers find so shocking about Kappa Cassiopeiae, but that joke sounds so dumb that I'm not going to say that. The location on the Earth's surface corresponding to the position of Kappa Cassiopeiae in the sky is within the small location of Storset, Norway, which is within the municipality of Tingvoll to the west of Trondheim. More specifically, the location is the starting point of a trail leading up to the top of the mountain Norsko. This path starts near a parking lot in the forest, but the areas at higher elevation are covered in grasses and scrub. The mountaintop at 450 meters has excellent views of the surrounding area, and you may be able to relate the winds buffeting the peak of Norsko with the winds from Kappa Cassiopeiae buffeting the surrounding interstellar medium. The entire trail is 2.5 kilometers in each direction, which is much shorter than the distance to Kappa Cassiopeiae, and the hike is relatively easy. Let me know if you try this hike and what you think of it. You can contact me with the details at www.randomastronomicalobject.com. You can also go to the website to download episodes of the show, read information about the astronomical objects, view images of those astronomical objects, and look up additional reference information. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, and the sound effects are from the Free Sounds Project at www.freesounds.org. Thanks for listening.